welcome to another WJEC A level physics question. This time it's PH4 from June 2004, question 3, a question on circular motion, which is nowadays found in Unit 3. We're told first of all that the acceleration A of a body moving at constant speed in a circle of radius r is A equals omega squared r, and we've got to say what omega represents. Well, we can call this a number of things. Most commonly we would call it the angular velocity, but we could call it the angular frequency or the angular speed. As long as we get the angular in the answer, we're okay. Next, we've got to show that the formula may also be written as A equals V squared over R. Well, the key to this is the use of the equation V equals omega R. So if we take a rearrangement of that, we have omega is equal to V over R. Take the original equation, replace omega by V over R, all squared. That's going to be V squared over R squared. Sorry, I forgot the R over here. And then we can simply cancel the R's. And we end up with V squared over R as required. Next, a car of mass 750 kilograms is driven around a semicircular track APB of radius 30 meters at a constant speed of 12 meters per second. And we've got to calculate the instantaneous centripetal force on the diagram when it's at point P and show the direction of this force by adding an arrow to a diagram. Well, centripetal force is the resultant force towards the centre of the circle, so we can simply apply Newton's second law or simply use the formula given in the data books that the centripetal force is mv squared over r. So if we plug in the figures, we have 750 times 12 squared over the radius of the track of 30. So let me just quickly put that into the calculator. And we end up with 3,600 newtons. Centripetal, remember, means directed towards the centre of the circle. So if we're going to add an arrow to the diagram, we're just going to direct it from P towards the centre of that circle. Next, it tells us that the car takes 7.9 seconds to travel from A to B, and we've got to calculate the quantity, the change of momentum, the car's momentum at B, take away the car's momentum at A over the time taken to go from A to B. So the top bit is basically the change of momentum, and whenever we find a change, it's always final, take away initial, as we have in the question here. But we've got to remember that momentum is a vector quantity. So we've got to remember that if we want to subtract a vector, so let me just give you an example here. If I want to find the change of momentum, which is the momentum at B, take away the momentum at A, then we do that by taking the momentum at B and adding to it the negative of the momentum at A. So the momentum at B, going back to the diagram, would be a downward momentum. The momentum at A would be an upward momentum. So negative of the momentum at A would be a downward momentum. So if we wanted to do a simple vector diagram here, we could have the momentum at B in that direction, the momentum of A, but the negative of momentum A in that direction. So the change of momentum you can see here will be double the momentum of either PB or PA, because they're going to have the same size momentum, simply found from mass of 750 times a velocity of 12. So the length of our resultant here, delta P, would be 750 times 12, but doubled, which gives us 18,000. And then the calculation that we have to do, the change of momentum divided by the time, we've just got 18,000 divided by 7.9, which will give us 2,300 roughly. This quantity, as we're going to see in the next part of the question, is a force. So we're going to give it the unit of newtons. We could call it kilograms meters per second, but that's kilogram meters per second squared, and that is newtons anyway. The direction of the quantity, well, we've got a north direction marked on the diagram here, and looking at our vector diagram to the left, we can see that the direction of this would be to the south. State the significance of the quantity that you've calculated, and as I mentioned on the last part of the question, it's a force, and what it is the average force or the mean force acting on the object as it moves from A to B. So thank you very much for listening. Please remember to like and subscribe, and feel free to leave any questions or comments below. Goodbye.